Okay, already on our sample problem number 2 for our module 13. So we have a given disk here. We have a 3 kilogram disk D. So this is the disk, and it is the mass of this disk is 3 kilograms, and this is attached to a cord. So this is the cord, and the other end of the cord is attached to a ball and socket joint. So this is the ball and socket joint, and which is also at the same time this is the center of the platform. If the platform rotates rapidly and the disc is placed on it and released from rest as shown, determine the time it takes for the disc to reach a speed great enough to break the cord. The maximum tension the cord can sustain is 100 newtons, and the coefficient of kinetic friction between the disc and the platform is, so kaning mu k is mo niya ang symbol sa kinetic friction, coefficient of kinetic friction is a 0.1 ang iyang coefficient of kinetic friction. So again, naa natay chord nga involve ani. So by static, if we analyze this as a static body and then it hangs vertically, ang tension sa cord, so ang kaning cord diri nga naka attach sa disc, di ba? If it turns around, ang disc kay mura mo gini siya malabay paingon didto. Sa ato pa, the cord experiences tensile force. So we know that if the object is in motion, so na siya acceleration, and then there is an unbalanced force. So for this example, ang unbalanced force is nasa tangential and then outwards. So the more nga increase ang acceleration, the more that the unbalanced force will also increase. So mo na siya ang concept man nato diri. And then we have so mo na siya ang motion sa platform. So it moves in a circular direction. So same lang gyapon no, if it moves that way. So this is our problem number 2. If moves like this, so ang katong direction sa motion, that is the tangential acceleration. We have the normal acceleration towards the center always, and then our binormal acceleration. Actually, we don't have a binormal acceleration, but this is our binormal axis, and then we have here our normal axis, and then diri ang tangential axis. We just use the symbol T. So ang radius here of the cord is 1 meter. Okay, so atong isulat ang given no. So ang tension do sa cord, so ni maximum tension of the cord is 100 newtons. And then we have the mass of the disc, which is equal to 3 kilograms. So the weight of the disc then is just the mass times the gravitational acceleration, that is equal to, so 3 times the gravitational acceleration, 9.21 meters per second squared. We have 29.43 newtons. And then what else? What's sa to? Okay, we have the coefficient of kinetic friction, mu k, that is equal to 0.1. Okay, now what we were asked, so we were asked if the platform rotates rapidly and the disc is placed on it and released from rest as shown, determine the time. So we were asked the time it takes for the disc to reach a speed great enough to break the cord. So sa may naani speed o kuno break great enough to break the cord. Okay. So again, we have 3 axes here or 3 coordinates. We have the normal, the tangential, and the binormal axis. So if atong i-drawing si disc no, let's say we have this this here. So it moves along this way, di ba? Let's say it moves along this way. Sa ato pa, we can say that this is the tangential component. And then this is the radius. So nadri ang along here is the center. So this is the normal. And then here is the binormal. normal. So along the binormal component, we have the weight of the disk. So ang weight sa disk, which is equal to 29.43 newtons. And then what else do we have? We have also here a force here along this side. We have the tension. So tension is always moving outward the body. So if this is the body, it moves outward. So this is the tension. What else do we have? We have also a friction, and then we have a, yes, so on this side, so the friction is just equal to 0.1 of the normal force given by this disk. So since ang name sa disk is D, so we can denote that as ND, N sub D. So do pwede na dili. So here on the normal side, we have a normal acceleration. On the tangential side, we have the tangential acceleration. And the binormal side, we don't have the acceleration. So what do we do next? So again, just like the previous problem, we sum forces. So we sum forces along the normal direction. We have the summation forces along the normal direction is just equal to the mass times the normal acceleration. So ang force along the normal acceleration, if inyong tan-awon ang drawing, that is just, so wala man siya naka-incline. So usa ray force along the normal direction, that is the tension, is equal to the mass, which is 3 kilograms, then the times the acceleration. So acceleration, di ba, is the normal acceleration is equal to v squared over rho. And then we know that the radius of curvature, or the radius of this movement, this is moving in circular path, is it was given here, that is equal to 1 meter. So our tension then is just equal to 3 times v squared over 1, or simply the tension is equal to 3v squared. Let's say this is our equation 1. Next is we sum forces along the tangential component. So that is just mass times the tangential acceleration. So ang force along the tangential component, we just have this one due to friction. So that is F is equal to mass, which is 3 kilograms times the tangential acceleration. And since ang atong friction is equal to mu k times the normal force due to this, so that is equal to 0.1 normal force of the disk is equal to 3 times the acceleration due to tangential acceleration. Let's say this is our equation 2. And now we sum forces along the binormal component. So that is just equal to 0 because there is no acceleration in the binormal component. So ang force along the binormal is just the what? There is a normal force here. So that is the ND, and then we have the weight. So that is equal to the normal force, and D minus the weight is equal to 0. Therefore, the normal force is just equal to weight, which is equal to 29.43 Newton. Sa ato pa, si normal force is just equal to 29.43 Newton. So we already have the normal force and D. So substituting it on this equation, then we can get for the acceleration. So unsa man ning anong magkuha na to sa acceleration? If we can get the acceleration here, so we will have a tangential acceleration. So we can also get the velocity here on this side. So so we have the, what is that, tangential acceleration? So that is just equal to 3a T is just equal to 0.1 times the normal force, 29.43 Newton, divided by 3 divided by 3. Our tangential acceleration, that is just equal to 0.1 times 29.43 divided by 3. That is equal to 0.981 unsa unit. This is SI, therefore this is in meters per second squared. So but we are not yet done because we were asked what is the time. We have the acceleration. Actually, this one here, masolve na to si velocity. So saan na to pag-solve si velocity? Let's assume nga na mabugto na si cord. Okay, so saan na to ni? Again, ang ato ang tension, di ba nga maximum is pila to? We have the 100 Newton. So at this tension, 100 Newton, this is the critical force, the maximum tension. Beyond this, mabugto na siya. So our critical velocity, we call that critical velocity because this is our maximum tension. So we substitute this value of tension on equation 1 here. We have 100 is equal to 3 of v squared. So our velocity then is equal to, so we have a 100 divided 3 and then square root of that, we have 5.7735. 5.7735 meters per seconds. And then what happens next? So our tangential acceleration, actually this is constant. And then sa may buhaton na to, if this is a constant, then therefore we can use our previously learned kinematic equation on constant acceleration. So we have the velocity, and then diretso na nato ma-solve si kwan. So we have the what formula we are going to use. We have the final velocity is equal to the initial velocity plus the acceleration times the time. So ato magipangita is si time, di ba? And then we have also the final velocity squared is equal to square of the initial velocity plus 2 times the acceleration times the displacement s. We also have the s is equal to the initial position plus the initial velocity times time plus 1/2 times the acceleration t squared. So asa man nato magamit diri? We cannot use this one. So this is a known. Let's see, we have this known. We know this one. We know this one because it starts from res. Let's see, we have the acceleration, then we can solve for s. But we don't need to solve for the position because we need the time. So sa ato pa na running duha ang ato ang kuhaon. So kung ato pa isolve sa positions, actually, so s minus s naught, this is just the delta s. Actually, this is already a waste of time kaya taas na kaya ito pag-solve. So ito pinakadali nga solve is we use this formula. So this is just the, we just use the critical velocity here. So this is the v is equal to the initial velocity, which is 0 because it starts from rest, plus the acceleration nga itong gamit diri. This is not the normal acceleration. This is the acceleration. Kung unsa ang velocity nato, di ba, is tangential sa to pa, the acceleration here is also tangential plus the tangential acceleration times the time. So we have the final velocity before it breaks, that is 5.7735 meters per second is equal to 0, which is the initial velocity, plus 0.981 meters per second squared times the time. Then here, we can solve for the time na makuha na to. Okay? So for the time, we have 5.7735. This is 0 divided by 0.981. So after 5.885 seconds, kani siya nga time mo, abot na siya sa maximum tension, then eventually, the cord, kani diri nga naghawid sa disc, will eventually break. So, moro ni siya, no? So, actually, atong gibuhat ra gyud is, kung before nag-sum forces ta along the normal and the tangential, now we will have the binormal component, and then there is no acceleration sa binormal component. We have the normal acceleration and the tangential acceleration. Ang normal acceleration, same formula gyapon, that is just v squared over rho. So we have given rho, which is the radius of curvature, which is 1 meter. So mo to gigamit diri. We some forces along the normal, tangential, and the binormal component. And then from the normal binormal component, we got the normal force due to disk weight. And then from the tangential component, we got the acceleration, tangential acceleration. So this is a constant acceleration. And then sa ato ang first from the normal component, we solve for the velocity. That is the critical velocity. This is called the critical velocity here. This is the 5.7735 because mo ni siyang velocity nga at that point ni-reach na sa maximum tension si cord. Eventually, it will break. So since the acceleration here is constant, and then we have the velocity just before it breaks, sa to pa, this is the final velocity. And then it starts from rest, so ato ang, we can use this kinematic equation. So this is 0. This is the final velocity just before it breaks. Kay mo man ni ang velocity nga mo 100 newtons na ang tension, and then after nas ma-break siya. And then we have the acceleration here, the 0.981 meters per second squared. And then therefore we can get the time. So the time is at 5.885 seconds.